Alright, now in the previous lecture we have learned how can we create a trie. Now in this lecture we are going to talk about insertion a string in a trie. Now when we are inserting a string to a trie, we have four cases. So let's look at them one by one. Now the first case is the trie is blank. So let's say we want to insert this word to a trie, and we have noticed that we have created a trie and the trie is empty. So how can we insert this string to the trie? So as we said before, the first thing that we are going to do, we are going to create a node and assigning to first letter of this string to this node over here. Now when we are creating a trie, we have created an empty root node. So this means that the first character of this string over here will be assigned to the root node of a trie. Now here we have a root node in which we don't have any character. So as we said before, when we are creating a trie, we are just creating a blank root node. So in this case, we are going to take the first letter of this string over here and assign it to the character part of this root node over here. So in this case, we are going to take A, which is the first letter of APP, and assign it to this node over here that we created before. Now after creating this, we have successfully inserted the first character of this string to this trie over here. Now the next character is P. So in this case, we see that we don't have any other node over here. So this means that we are going to create a new node for P, and we are going to create a link from this root node, which is A, to this P over here. So in this case, it's going to be like this. We are creating an empty node over here and creating a link to this empty node over here and assigning the second character to this node over here. So here you can see that in the character part, we have assigned P to over here. Now then we are continuing to the next character. So in the next character, we have again P. So this means that we have to create a new node over here and create a link between this P to this new node over here. So after creating new node, we see that this new node is empty. So this means that we have to assign the second P to this new node over here. Now after doing so, we have reached the end of string. So this means that we have to mention that this is end of string. So in case of trie, we are creating a child for an end of string and setting the end of string property to yes in this case. So if a child of a node is set to the end of string, so this means that this node is the end of string. So in this case, we are going to create a new blank node, and in this case, the property of end of string for this node will be set to yes. So here you can see that it's set to yes. So this means that the parent of this node is end of string. So this means that APP is a complete string over here. Now with this, we have successfully inserted a string to a trie in which a trie is empty. Now let's continue to the next case. Now the next case is new strings prefix is common to another strings over here. So in this case, it means that we have already inserted some elements of this new string to this trie over here. So here you can easily see that the new string is API. And here, if you look at this trie over here, you can see that we have already have A and P, which is the prefix of this API string over here. So this means that we are not going to create a new node for these two characters over here. So the first thing that we are going to do, we are going to take the first character and compare it with the root node. So in the root node, we see that we have A over here. So this means that we are not going to create any node for A over here. Then we are continuing to the node which is linked to A, because there might be some other characters which are linked to other nodes. So in this case, our string's first character A. So this means that we are going to continue to the node which is linked to A. So the node that is linked to A is P. So in this case, we see that this matches the second character of the new string that we want to insert. So here again, we are not going to insert any node over here. We are just going to stop over here, and we are going to continue to the next node which is after the P over here, because P is the second character of new string. So in the next node, we see that we have P again. So this means that in this case, the character is different, so we need to create a new node for I over here. So in this case, instead of creating a new node, we can just insert this character to the next node. So in this case, you see that after P, we have P over here. So if I add one more character to this node over here, it's going to be linked to this P over here, because from P, we have a link to this node. So if I add I, it's going to be the character that comes from this P over here. So this means that we are going to insert I to this node over here. Now after inserting this, we have to link to a child node over here, because we are going to check that if this is a complete string or not. So we see that this is a complete string. So this means that the node that is linked to I has to have a property of end of string. So in this case, we are going to create a blank node and we are going to set end of string to yes. So with this, we have completed insertion of a node in which the prefix is same as with the other string. So in this case, we have successfully inserted API to this trie over here. Now the next case is new string's prefix is already presented as a complete string. So this means that this string's prefix is a complete string over here. So if you look at this string over here, we see that this string is API-S. So this means that this prefix of API-S is a complete string over here. So if you look at this trie node over here, we can see that API is a complete string over here. So we have inserted API over here. So in this case, we want to insert API-S over here. So one more time, we are going to check the first character. So we see that the first character is same. Then we are continuing to the second character. So we see that the second character is also same. Then we are continuing to the third character. We see that the third character is also same. Then we are going to continue the fourth character. So in this case, after I, we have a blank node over here. So this means that we are going to insert S to this blank node over here. Now, after inserting S to this blank node, we have to mention that this is also end of string. So this means that we are going to create a child node for this S, which is linked to this S, and we are going to set the property of this child node to yes. So here again, you see that end of string set to yes. So this means that if we search for API, we will see that API is a complete string over here because after API, we have set the end of string parameter to yes. And if we search for API-S, we will see that API-S also is a complete string over here because after S also we have end of string property set to yes. So with this, we have successfully inserted a string to the trie in which the prefix is already presented as a complete string. Now let's continue to the next case. So in the fourth case, we want to insert a string which is already presented in trie over here. So for example, if I want to insert API-S to this string over here one more time, we are going to check that if the first character is matched to the first character, then we are continuing to the next character. So the next character also matched to this character, second character over here. Then we are continuing to the next character. So we see that in the next character, we have I, which is matched to the third character over here. Then at the end, we have S. So after S, we are checking that if the child of S is set to end of string yes. So in this case, we see that this is complete string over here. So we don't have to insert this node to this trie over here. It's already presented in this trie over here. So with this, we have learned 4 cases of insertion of a string in a trie. So based on this logic, we are going to head over to Java and implement this logic in practice. Now here, inside this trie class, we are going to create insert method. So insert method will not return anything. So that's why I'm going to declare it like this. Public void insert. So this method will take as a parameter string type of word. So this is the word that we want to insert in our trie over here. Now the first thing that we are going to do, we are going to create a temporary node which will keep the value of current node. So in this case, it's going to be the type of trie node, and the name of the node will be current, and initially it will set to root, because when we are starting inserting a node, first we are checking the root node. So that's why the initial node will be root. So we are setting current node to root. Then we are going to loop through the characters of this string one by one and check that if this character exists in the trie, we are not doing anything, we are continuing to the next character. Otherwise, if it does not exist in the trie, we are going to insert that character to the new node in a trie. So I'm going to write our loop like this. If int I start from 0, because the index starts from 0, it continues until the word's length. So this word comes from this parameter over here, so it will continue until the length of this word, and in each step is going to be increased by 1. Now then, I'm going to take the characters one by one from the word and check that if these characters exist in the trie or not. So the first variable that we are going to create will be the type of character, and I will create it ch character. First we'll get the first character from this word over here. So I'm going to use character add function with the index of I over here. Now after taking the character, the first thing that we are going to do, we are going to create another node over here which will get the value of this character from this map that we created inside this trie node over here. So as you remember, inside trie we have created a map over here in which we have a key as a key character and as a value trie node. We are going to get that node by using this character over here. So then after getting it, I'm going to set it to this node over here. So trial node is equal to current node dot children. We are going to use get method, get ch. So by using this get method, we are getting the value of this character in the map that we created. So in this case, if this node is equal to null, in this case, it means that we don't have any value for this character. So this means that we have to create a new node and insert it to these children's over here. Otherwise, we are going to continue to the next node. So after getting the value, we are going to check that if node is equal to null, in this case, we don't have this character in our trial. So this means that we are going to initialize this node that we created over here with a new node. So it's going to be new trial node. And we are going to set the value and we are going to set the current node's children's key and value set to this node over here. So in this case, this is a child of this character over here. So this means that it's going to be like this. Current.children.put is going to be ch.node. So in this case, we are adding this character to the trial and we are creating an empty child node over here. So with this, we have successfully inserted this character to the children over here. Otherwise, if the node has a value, in this case, we are going to continue to the next node. So in this case, we are going to set current node to this node and we are going to continue to the loop over here. Now, after inserting all elements to this try over here, we have to set end of string to true, because in this case, we can identify that this string is a complete string. So in this case, the end of string property of this current node will be set to true. Then we are going to print out to the console saying that this word has been successfully inserted to the trial. So it's going to be like this: system out.print, so successfully inserted. So I'm going to concatenate word over here, then I'll put in try. So with this, we have successfully completed insert method in try. So basically what we are doing over here is, first we are identifying the current node by setting the root node to the current node. Then we are looping through the character of the word that we want to insert. So each time we are checking that if this character exists in the trial, we are going to continue to the next node. Otherwise, we are inserting this character to the trial and we are creating an empty node as a child of this character over here. Now, after doing so, at the end, we are setting the end of string to true because we have to identify that this word is a complete word. Now let's see how this is working in practice. So inside main class, we have created our new try over here. Then I'm going to call insert method for this new try over here. So it's going to be like this, insert. So let's say I want to insert API. Now if I run our code, you see that the message printed out saying that successfully inserted API in trial. So let's run one more example to see that if this is working correctly for the next example. So here the cursor appears over here. So instead of calling print method, we need to put println over here to see the output properly. So here I'm just going to insert API S. So if I run our code one more time, you will see that in this case, it says that API S has been inserted to this try over here. So here you can easily see that API S inserted in the try. So we have successfully inserted API and API S in this try over here. Now let's see what's the time and space complexity for this method over here. So if you look at this method carefully, we see that we are looping through the length of word over here. So if the length of word is m, so in this case the time complexity will be om, because in this case we are looping all characters of the word. So this means that the time complexity will be om. Now the space complexity is also om, because in the worst case, if these characters are not exist in the trial, we have to insert all characters in a single node. So this means that if the number of characters is m, we have to insert m number of nodes to the memory. So this means that the space complexity will be om. Now with this, we have successfully implemented insert method in trial. So hopefully everything is clear about this method. Now in the next lecture, let's see how can we search for a string in a trial. So see you in the next lecture.